Hey guys, what's up everybody? Welcome back again to another video tutorial from the Apex Academy of Mathematics. We're learning the language of the universe begins here. And in this video, we're going to be talking a little bit about approximation, but specifically, we're going to be approximating or rounding off numbers to a given or a required significant figure. We're going to be going through some basic information, some introduction to what a significant figure is, the pros, the cons, the do's and the don'ts, and of course a few examples to of course help you to understand this concept a little bit better. If this is the first time that you're on my channel, please of course hit the like button below, smash that notification bell, and turn on your subscription button right now. All right, and if you have enjoyed my previous videos, please be sure to rewatch those videos that I've already posted for you. All right, so my name is Akin, otherwise known as Apex LNU. I am your math guru, and let's jump right into the video. All right, so as it relates to significant figures, we're going to be going through a basic definition, looking at what numbers are significant and what numbers are not significant, and of course showing a few examples and stuff. All right, so let's run through this information real quickly for you. A number is said to be significant if it's a non-zero digit or if that number is greater than 0. All right, and this sentence right here is somewhat ambiguous, meaning that there are instances where zeros can be significant, even though this statement here clearly states that a number is significant if it is greater than 0. All right, however, the reasons for why 0 or zeros can be significant is depending on the position that it has in the number, or the position that it holds in the number. All right, so depending on where the 0 is, we can safely say that this 0 or that 0 is insignificant or significant. Let's take a look at why and when zeros are significant or insignificant. It says here that if 0 or zeros appear before a non-zero digit, then those zeros are said to be insignificant. Take for example number 1 here. All right, if 0 or zeros appear before a non-zero digit, then these zeros are said to be insignificant, meaning that 7 right here is my significant value, or my first significant value. But since these zeros here appear before the 7, then those zeros are insignificant, meaning that no matter how many of those zeros I'll put before the point or after the point, as long as they appear before the first non-zero digit, then those zeros are said to be insignificant. They will not increase or decrease the value of the number. However, how can zeros be considered as a significant digit? It says here, if 0 or zeros appear before a non-zero digit, then those zeros are said to be significant. Here we have an example in number 2 here, where my first significant digit is actually the number 2 right here, but these zeros actually appear after the 2. In fact, they appear after the first, the second, and the third significant digit. So these zeros in this case here, based on their position, they are indeed significant, which means that if I were to remove one or both of those zeros, it will actually decrease the value of the number. All right, so that is how you can determine if 0 or zeros are insignificant or significant. All right, good. So I hope you got that concept. Let's continue, and if you're getting some value from this video so far, of course don't forget to hit that like button below. All right, so as we go to the next page here, it says here that we're going to be going through the rules of how you approximate a number to a particular significant figure, and this requires two very basic steps, which I've listed right here for you. All right, so the first step here, as I've written, is to identify the required significant figure. That's the very first step, is to identify the required significant figure. And this will be indicated by these notations here: 1 SF, 2 SF, 3 SF, and so on. All right, so they're saying that they want you to approximate or round off the number to the first or the second or the third significant figure. But remember that you count your significant figure starting from the left going towards the right. All right, and then once you've located that required significant figure, you're going to draw a line behind this digit. All right, that is step 1. And of course, step 2, which is the final step, is to check the digit that appears after the line that you have drawn. Now, if this digit is greater than or equal to 5, we will add 1 to the previous significant digit. All right, this will all make sense momentarily. However, if it's less than 5, then we ignore the digits after the line and rewrite the previous digits, or rather rewrite the previous significant digits. All right, so step 2 will make a lot more sense once I go into the examples that I've written over here for you. Okay, all right, let's pay attention to this note well that I've written here in red for you. When you're approximating numbers to a given amount of significant figure, you are to remember the concepts of 0 or zeros being insignificant or significant. Please bear that in mind, because sometimes it does give students quite a bit of headache, especially as simple as this math may be. A lot of persons do, of course, overthink the question and get it incorrect. All right, and also you must note here that significant figures have no specific starting position. All right, well, in fact it does. You have to start from the left to the right, but you do not say, hey, I must start before the point, or I must start after the point. Wherever you spot your first significant figure, that's where you start counting from. All right, wonderful. All right, so let's jump right into the examples to see how best this can make sense to you. Okay, so wonderful. Let me change my ink here so that you can have better understanding of how this concept here works. All right, good. All right, so example number 1, you're given the number 0.004137, and you're asked to approximate this number to one significant figure, 1 SF, right here, as was indicated on page 2. All right, so I notice here that these zeros here are insignificant because they appear before the 4. So my first significant digit here is, of course, 4. So I will draw my line, because this is my required significant figure. I will draw my line right here behind the 4. All right, that completes my step 1. I identified my required significant figure, then I draw a line behind this digit right here. My step 2 says here, I'm going to check the digit that comes after. So the digit that comes after the 4 or behind the line is 1. Now, if this digit is greater than or equal to 5, I would naturally have to add 1 to the 4. But because this number is less than 5, I will simply ignore these digits over here. I will ignore these digits over here, and I will just rewrite the 0.004. And so you can see, before I did the approximation, I had 4 significant figure, but now because of the mathematical approximation, I've rounded my number down to only 1 significant figure here. Now please note that even though the zeros are insignificant, they are still a part of the number. So once you have done your approximation, these zeros must be written back, because they are what makes up the number. Or you could simply say 0.4. You could say 0.4 for your answer. All right, good. All right, so let's get into example number 2 here. Let's just do a little erase here. Okay, good. All right. So for this number, we have 0.30147, and we want to approximate this number to 4SF. So this 0 is insignificant, but so this is my first significant figure. Now, since this 0 appears after the 3, then this 0 is of course significant. All right, this 0 is of course significant. Let me just rewrite my 3 here. All right, good. So this is my first significant figure, my second significant figure, third, and my fourth. This is my required significant figure right here. So I need to draw a line right after the 4 right here. Okay, now I will check the number that comes after the 4. And now recognizing here that this number here is actually greater than 5, I will simply have to add 1 to the previous significant figure, and the previous significant figure is actually 4. So my answer will turn out to be 0.0, well, not 0.0, but in fact 0.301, and I add 1 to the 4, I'll get 5. And that is my solution to that question. All right, so hope you're understanding so far. Let's run through the remaining examples here. So we have 347.012, and I want to round this off to 2 significant figure. Now with this example, this is one of the examples that gives students many issues. They will assume that they get it right, and of course they most often get it incorrect. All right, so my first significant figure here is 3. My second significant figure here is 4. So I'll draw my line right after the 4 here. All right, and I will check the number that comes after the 4. That number again is 7. So since 7 is greater than 5, I will add 1 to the 4, and I will get 3, 5. But here is the thing now, that the error that students make. Once they have done that step, they do not recognize that approximating a number will not decrease the number extensively or increase the number extensively. The number needs to be within the same range, not too far from the exact value of the number. So of course, to get this number to be near 347, we need to add a 0 as a placeholder to keep this number here as being close to 347. All right, so please watch out for this example during your practice session or on your exam papers or assignment paper. All right, let's run through the final 2 examples here for you real quick. All right, 0.001496 to 3 significant figure, and of course by now you will realize that these zeros are indeed significant, or I should say insignificant. So my first significant figure here is 1, second is 4, and my third here is 9. This is also another tricky example, all right, where students make an error. So I'll draw my line right after the 9 here, and I'll check the number that comes after, and that number of course again is greater than 5, so I'll add 1 to the 9. But 9 is the largest in our decimal system. So what happens when I add 1 to 9? Do I get 10? Yes, you get 10. However, you cannot rewrite the 9 and write 10. You've simply got to write down the 0 here and bring the 1 from the 10 onto the 4, and you're going to get 5, and then you rewrite your remaining digits right here. So the answer actually turns out to be 0.00150. Now when this situation occurs where when you add 1 to 9 you're going to get a 2-digit figure, what I often tell students is, rather than adding 1 to the previous digit, I add 1 and I take a look at 49 instead of looking at the 9. So when you add 1 to 49, you're going to get 50. That trick helps a lot of students sometimes. So just look out for the example where you have to add 1 to a number and it becomes a 2-digit figure where you have to carry over. So do pay attention to this example especially. So I add 1 to 9, I get 10, I write down the 0, bring the 1 onto the 4, add it to the 4 to get 5, and I rewrite my remaining digits. Okay? All right, so now I got 0.0 150. All right, and for my final example here, I have 0.04205. I wanted to add this one to it here, where we have third significant figure. These zeros are insignificant right here, so my first is 4, second is 2, and my third here is 0. And so I wanted to show you an example where the number is actually 5. So the rule states that if it's greater than or equal to 5, I will still have to add 1 to the previous significant digit, which is 0 here. So I add 1 to 0 and I'll get 1. So my final answer here is 0.0421 for 3 significant figure. All right, good. All right, guys, so that brings us to the end of this video tutorial for approximating numbers to a certain amount of significant figures. If you have any issues with this, please, of course, rewatch the video and be sure to press like and smash that subscribe button below and turn on your post notification bell for future tutorials. Coming up in my next video are approximations to decimal places and rounding off numbers, rewriting them in its standard form. All right, so please look out for those tutorial videos. My name is Akin, otherwise known as Apex Selenium, your math guru, and thank you for watching this tutorial video from the Apex Academy of Mathematics. We are learning the language of the universe begins here. Do take care, and I'll see you next time.